How's everybody doing out there? Well, welcome to day 2 of Corona Online School. So, hopefully, everybody did a good job and survived day 1 and is ready to start back at it for our second class. So, in this class, we're going to continue on with more figures in the plane. So, again, we're going to start off with a bunch of definitions in this case. So, if you want, go ahead and actually pause the video or stop it altogether. Go look at the PowerPoint slide that has the definitions, go through and actually write them all down. There's a matching picture to go with each one. Some of them have notations. Most of them in this section don't have notations. But go ahead, fill that out first, then come back and watch the video, and then I'll actually walk you through. I don't want to read all these definitions off to you or anything like that. So when you're done, just come on back or restart the video, and then we'll be ready to dive in. All right. Well, hopefully everybody was able to get all the video or the definitions written down. So the first thing we want to talk about, and this is going to come in handy when we're doing some problem solving stuff, are these three properties: the corresponding angles property, the alternate interior angles property, and the same side interior angles property. So if we look, so remember, corresponding angles are going to be the angles that kind of are in the same position. So like if you looked at the definition, like in this case, if I think of this as, oops, got the eraser on. So like position 1, position 2, position 3, oops, position 4. Hold on, I put 3 in the wrong spot. 3. Then this one and this one would be corresponding angles because they're in the same spot. So the way I like to think of them is kind of like upper left, upper right, lower left. So these are going to be the corresponding angles. They're going to be the ones that kind of match up. And so the cool thing is, if the lines that intersect that transversal happen to be parallel lines, which case these are, then these corresponding angles actually have the same measure. So like in this case, angle B and angle A are corresponding angles, but they also have exactly the same measure. So same thing for C and for D. So these corresponding angles have the same measure. So it's true with these up here, I just didn't color them in, but this guy here is going to have the exact same measure as that guy, which turns out it's going to be 127 degrees. And then this X, or this little star, is going to have the same angle as that guy, and it turns out it'll be 53 degrees. So again, we're going to use this later when we're doing some problem solving stuff, so kind of keep track of that, keep it somewhere where you can access it. All right, so let's go to alternate interior angles. So the main thing to remember about interior angles is what they're talking about is the space in between the two lines, in between the two, not the transversal. So like in this case, like this part would be considered the outside, down below would be considered the outside. So the stuff in between would be the interior. I guess it should be using exterior instead of outside, but hopefully you know what I mean. So in this case, what we're saying is that alternate interior angles, so it's going to be the angles that are on the opposite side of the transversal. So in this case, this angle and this angle are alternate because they're on opposite sides of the transversal, and they're interior because they live in between the two lines. So again, the nice thing about these guys is alternate interior angles have exactly the same measure. So again, in this case, we can see that angle C has a measure of 127, angle D has a measure of 127, and similarly, B and A both have a measure of 53, and so again, they're alternate interior, they're on opposite sides of the transversal, and they're in the interior of the two lines. All right, very good. So finally, the last one here is same side interior angles. And so in this case, so again, we're talking about the interior again, so we're looking in between the two lines. But instead of being on opposite sides, in this case, they're on the same side of the transversal. But in this case, notice they're not equal to each other, but they are supplementary. And if you remember, supplementary means that the angles add up to 180 degrees. And so if we notice, 127 plus 53 actually gives us that 180. So again, I'll show you how we're going to use these in just a little bit when we're actually going through some problem solving and stuff like that. But keep those in mind. Go back and reference them if you need to. They're nice little things to remember. There'll be some of those on the homework to practice also. So, all right. If you have any questions about that, definitely let me know. So otherwise, what we want to do is, so remember last time we talked about a postulate, which was something that we knew was true and didn't have to actually prove it. So a theorem is similar to a postulate. It's something that you need to, it is true, but you have to kind of show it's true. So in this class, we're not doing much with proofs or anything like that, but in higher up math classes, that's what you do. You kind of prove theorems are true and things like that. So the two that we've got here, and so again, this will kind of help us when we're doing some of these problem solvings later, is the vertical angles theorem. And the vertical angles theorem says that vertical angles have the blank measure. So if we actually go up to this very first one, so remember I said that this guy had an angle of 53, and it turned out this guy has an angle of 53 also. Well, the reason being is those two angles are vertical angles, so they're exactly the same. So that's what our first theorem tells us here. The vertical angles theorem tells us that vertical angles have the same measure, so they'll be exactly the same degree. All right, so 2 is the alternate interior angles theorem. So this one kind of piggybacks off of this one, but it actually kind of works backwards in this case. So in this case, we were saying if two parallel lines were cut by a transversal, then the alternate interior angles have the same measure. So in this case, it's kind of saying that you could go back and forth. So two lines cut by a transversal are parallel if and only if a pair of alternate interior angles is the same. So in math, when you see an if and only if statement, what that means is you can actually read this theorem kind of forwards and backwards. So it could be written so as if two lines cut by a transversal are parallel, then the pair of alternate interior angles is the same. Which, if you remember, is pretty much exactly what the alternate interior angles property is. So basically these properties that I showed you are also theorems, is another way to think about it. But it also allows us to kind of work backwards and say, well, if we are given a pair of alternate interior angles with the same measure, then that means the lines had to have been parallel to begin with. So again, this kind of allows us to work back and forth. So if we're given that we have two parallel lines, we know our alternate interior angles are the same. If we know our alternate interior angles are the same, then that means our drawing had parallel lines. So that's kind of what that theorem tells us. So again, if you have any questions about that, let me know or anything. So otherwise, let's move on to some actual math here. So in this case, part 2, we've got a nice little drawing. It's telling us up front that line AB and CD are parallel. So this is line AB. This is line CD. And then we also know that angle BCF is a right angle. So remember, the way these angles work is the center letter is always going to be kind of the middle of the angle. So what I'm tracing out in this case, BCF, starts at B, goes to C, and goes to F. So make sure you're careful because we're going to be filling out some angles and you want to make sure you're actually doing the right one in that case. So that's our angle BCF. So since it's a right angle, we know that that means it's 90 degrees. So if you wanted, you could put the little thing there like that to show that it's actually 90. All right. So I'll leave 1 and 2 for you guys to do, just so that way you're trying to figure out which ones are parallel, even though I kind of told you, but you're applying the symbol to them that you'll learn from the definitions. And then same thing, we kind of gave away what the perpendicular was, but then just use the symbols to represent it. And then for 3, I'm going to have you try these guys on your own also. So again, this is applying the definitions and seeing if we can figure out which ones of these guys are. So which one are concurrent lines, which ones are supplementary angles, which ones are alternate interior angles, which ones are adjacent angles. So if you get stuck or if you have any questions on them, feel free to let me know. But otherwise, I'm going to let you guys try those. And what I want to do is get you started on this one. So I'm only going to do a couple of them just to kind of get you going, to get you the idea. And again, this is going to use all those properties that we were looking at before. So again, notice it's exactly the same picture. BCF is still a right angle, but in this case, they've given us a little bit more information. They've told us that angle BCD is 35 degrees. So in this case, I've got B to C to D. This guy is 35 degrees. And surprisingly enough, just by knowing that and the fact that BCF is a right angle and these are parallel lines, I can actually fill out all the other measures of all these different angles in that case, which is kind of crazy. So what you want to do is kind of use the different theorems to plug away, use some of the things that are there. So like one easy thing that we could start off with right away is, since I know BCF, let me draw it in a different color. Since I know this guy is 90, but I know this little part of it is 35, that means I can figure out this section by just doing 90 minus 35 in this case. So I'll make an 8, so that'll become a 5. So that gives me 55 for the measure of angle DCF. So if I look, let's see, DCF is right here. And you don't feel like you have to go in order of these. Like what I'd actually probably do is draw all the angles on the picture and then go down later and actually figure out where they land in the paper. And then once you've got that one, then start using some of the other properties. So like for example, if this is 55, what can I say about this angle over here? Well, hopefully someone in the class at home is yelling out 55, 55. Because it's a vertical angle. These two guys are vertical angles. So this guy is going to also be 55. So now from there we can start using the alternate interior angles, corresponding angles, things like that to kind of fill out the rest of them. So I'll leave the rest of that for you guys to fill out. Definitely ask if you have any questions or anything like that. But I think this is a good exercise. There's some homework problems like this, so it'll be fun for you guys to work on. All right. So part 3 is going to be our little exploration, and it's also going to be our collaboration this time. So the goal is, on the next page, I've printed off some really, really big triangles. And so your goal is if you've got a printer, if you don't have a printer, like you can just kind of trace these and then do them on your own. But the goal is I wanted you to rip off the corners of these triangles and then try to match them on this straight line, and kind of see what happens when you actually match these on the straight line. So you're going to do those 2 triangles that I provided. And so again, if you don't have a printer, just try to trace them as well as you can. And then what I also want you to do is make your own 3rd triangle, any size and shape you want. So try to make it different than the ones I drew. And then do the same thing, rip the corners off of those guys, line them up on the line, and see what you notice about that. And then hopefully we're going to predict what the triangle sum theorem actually is. So what I want you to do on the collaboration is, after you've kind of ripped them off, take pictures of each of your ripped corners on the line, just so we can get an idea of what it looks like. And hopefully we'll all come up with the same answer for that guy. So again, if you have any questions, just let me know. So otherwise, let me skip ahead here. So this one's too bad. So unfortunately, we don't have the Exploragons because we're not in class or anything like that. So if you have a protractor, you can actually kind of do this and draw these guys out. If you haven't gotten a protractor yet, go ahead and try to get one because we will use it some in the class. Again, I went to Staples the other day and got a really nice set that had a protractor and a compass and a bunch of other stuff for like $4. So they're not super expensive and they are kind of handy to have. But the goal is what we're going to do is try to go through and try to sketch and see if we can actually sketch these possible triangles. So if I get two angles, can I actually sketch, a triangle with these two angles? And it's going to relate back to this theorem that we're going to come up with. So in reality, if you figure out the theorem, you wouldn't have to actually go through and draw them, but it is kind of a cool thing to go through and draw them. So I'm going to leave that for you guys to try on your own. If you don't have a compass, there is a nice app that I can use. I'll post a link tomorrow on the site. So that way there's a compass that you can use, or not a compass, a protractor, like kind of a virtual compass that you can use on the computer. So we might be able to do it that way. So I'll post a link tomorrow so that way you guys can try it if you don't have a compass. And then otherwise, the last couple here are just practice for you guys. So again, kind of work on these on your own. 2, 3, 4, and 5, I think, are the exit ticket for the day. So you definitely want to make sure you do those. And I'll be around the computer all day tomorrow. So if you have any questions or anything like that, feel free to ask. Otherwise, I'll see you tomorrow.